Welcome to a video on AP Human Geography. Very, very cool. We're getting into population distribution. So we talked about scale of analysis, human-environment interaction, cluster, dispersal, just reading maps in general in the last unit of AP Human. Now we're going to be getting into population and migration and all that fun stuff. Very, very cool. So what influences population distribution? Well, many factors influence population distribution. As we can see on this image here, climate can influence population distribution. So precipitation levels, the temperature. Some people like to live in hot places. Some people like to live in colder areas, or just temperate climates in general. Some people like living near bodies of water, maybe to practice agriculture, or because it's cooler in that area. Some people like to live near landforms or away from landforms and stuff like that. An example of landforms influence population distribution is in this image here. We see less settlements on the mountains, so we see more distribution and clusters on that flat land area in these valleys and stuff. So that's very, very cool. So here we have three requirements, and we're going to be taking different scales of analysis to find population distribution and explain it a little bit. So we have a description about someone who wants to migrate to North America. They want a computer science job. They want to live somewhere it's not too hot but not too cold, and they want to stay closer to home, which is Japan, to travel. It's not said, but they want to travel. So here we have a map of North America. This is our scale. We're at a continental scale. So here we go. They want to say they want to live in somewhere that's not too hot. So that's going to rule out southern Florida, southern Texas, and a majority of Mexico closer to the equator. They also want to live somewhere where it's not too cold. So that's going to rule out a chunk of Canada and Greenland as well. Now they want to live closer to home to travel. And it takes longer to travel living on that east coast of North America. So let's rule out that east coast, kind of get to that central area. So we focus more on that central, Midwest, and the west area. Now they want a computer science job, and if you know anything about California, Silicon Valley's in California, near San Mateo and San Francisco. So let's put them there. Anyways, now they're in San Francisco. They're living near home, and they're not, not too hot, not too cold, that sort of thing. In each part, every time we shaded out a new area, we created a different scale and different scale of analysis. So that's very, very cool, by the way. So what are some methods to calculate population density? So we got to calculate population density. We're going to do some math. I mean, not much math. We're just going to learn how to do the math. We're not actually going to do it, though. So the first one is arithmetic density, and this is the total number of people divided by the total number of land in a given area. So when you see a map that just says population density, this is what you're looking at, the arithmetic density. So here we see population density per square kilometer. This could have been mile, feet. I mean, it would be a little more crazy if it's feet, but it's population density per square kilometer. We're not looking at anything about farmland, about the jobs people are in, or, the birth rate or death rate in the country. Just the people that are there currently, no matter what their age is or gender, per square kilometer. And this could have been any other unit of measurement. Very, very cool. So we see our most populated region, East Asia, is pretty dark. South Asia is pretty dark as well. Then there's physiological density, which is the total number of people divided by the total number of arable land in an area. What's arable land, you may ask? Well, it's just land that can be used for farming. It's going to be probably that flat land that could be used to grow plantations and stuff. Then that hilly land, which can be hard to grow crops commercially for money. So that's very, very cool. And you're going to be using physiological density for something else. You can also be able to determine an area's carrying capacity. And what is carrying capacity? Well, this is the max number of people the environment can support in an area. If a country exceeds its carrying capacity, people might start dying because there's not enough resource to support that population. This could be food, resources like water, shelter, all that crazy stuff. Here we see a map of physiological density. We see countries like in Western Africa that are now darker, but we're lighter in our arithmetic density map. Some countries like Bangladesh and South Korea are still dark on this map, though. Then there's agricultural density, our final one, which is the total number of farmers divided by the total number of arable land in an area. So it's physiological density, but it's farmers instead of just all the people. And here we can see agricultural density. It's not arithmetic density. Screw the key. It's wrong. So agricultural density, we can see here countries like Bangladesh and South Korea still have a high agricultural density. But look at the United Kingdom and the Netherlands. They're now darker on here, which is different from our two other maps that we've seen. Of course, they were still kind of dark. They weren't very light. But, they're still pretty dark. They're darker now. So that's very, very cool. All right, here I have a table of arithmetic density and physiological density for two made-up countries. So something you could use about comparing and contrasting different types of population density so you can determine data about the country, maybe its development, and then, of course, imports and exports. So I'm going to minimize that and ask a question. Which country most likely feeds their population with crop imports? If you said country A, you are correct. They have a higher physiological density, less space for farming with their population. So they're going to be importing more crops to feed and supply that population. Now, which country most likely grows their crops to feed the population? They're going to grow it themselves and create crop yield. Well, this is going to be opposite to the last one, country B. They have a lower physiological density and more farming space for its population. Now, which country is less developed? This one's going to be country A. And why is this? Well, the arithmetic density is really going to be used to determine our development level. The lower the arithmetic density, most likely means the less developed is. Higher arithmetic density, more developed. Higher physiological density, more developed. But in this case, we don't see a high contrast between we see a high contrast between the arithmetic density and physiological density, with physiological density being higher, extremely higher, than country B. So it's less developed. So very, very cool. Now, do you want more practice with population distribution or other APHUG concepts? Well, I got some stuff for you that's on the link on the screen. So this is very, very cool. Yeah, so click on it. I guess you can't click on it, but yeah, just go to it. It's case sensitive, by the way. It's free. It has some MCQs and FRQs and a way to contact me without doxing me. So there's a scale check. You guys can do it if you'd like. It's it's 6 parts. Yeah, 6 parts. It's a very cool FRQ. I actually had trouble making this, but I think it's still very, very helpful. So I recommend doing that. And you guys can go check out more AP Human videos if you want to go check this out. Please subscribe and like the video. That really does help me out. It's free. You can change your mind later on. Leave a comment, criticism. I love criticism. And yeah, go check out some more AP Human videos and do a scale check. I'll see you in the next video, guys. So adios.